Hello, Marcus.
Hello, hello. We'll use my first name. Right, can I invite some people up to speak? No, I need to tell you who they are. So we've got Gbo, G_Bo.
Maybe they can just raise their hands because I
Yeah,
end up like
yeah,
going.
yep, Gbo, AIDS, and Medfield. Gbo's, yeah, perfect. AIDS is in there. Gbo, raise your hand.
And is this Ahmed?
This is Ahmed, yes. Do
Hello,
you know
Ahmed.
Ahmed? Have you met Ahmed before?
Hello, everyone.
I snoop all the teams on on Btensor.
Very good. Gareth now has his hand up as well. Good evening,
Okay.
Mr. Fish.
Kant doesn't eat Snoop. He also loves what you've done with your shower curtain mug.
What I've done with what? The
Your
shower
shower-
curtain.
Yes.
There is no shower curtain. We all know that. Right, we're here. We also have Medphil in the chat, who will be answering technical questions in the chat. Presentational English on stage is not his forte. Neither is a high quality microphone. So he will be in the trenches in the chat if you have anything about the incentive mechanism. Const, do you want to talk a little bit about BitTensor before we go into this, or
One question before I do. We have Lewis Forbes has raised their hand and turned it on again.
Never.
Don't know him. Don't worry about it.
No,
Okay. Lewis, you can come on later, perhaps. So yes, quite an eventful couple of days for OTF and a lot of us behind the scenes. Well, I guess we should just tell a story of what happened. It's not the first time that Ala and I have experienced extremely traumatic events in the world of substrate and blockchain technology. And I want to talk a little bit about why we're even building on a blockchain first, because sometimes when these kind of things happen, you want to say, well, just use a goddamn database. But there's a really good reason why we built on substrate. And the main reason is that we have a trajectory to get to an increasingly more potent version of decentralization, more serious versions of decentralization over time. That's a massive aspect. And I'll talk to that in a moment and how this event is going to stimulate that. But another good reason is that we have a consistent, verifiable history of everything that's occurred. So that's why when we go take the chain into safe mode and come out of safe mode, everyone can see that nothing has been modified, nothing has been tampered with, and every single operation on the chain is cryptographically signed and consistent with the state. That's really important. So even though we have to do things behind firewalls occasionally to keep the chain moving smoothly and safely, everyone can go and see that nothing nefarious has happened. That's super important. But let's talk about decentralization. So substrate chains out of the box are not decentralized. So they're proof of authority, which is a pseudo form of decentralization in that you have a set of nodes and it's difficult to take down the entire network without taking down all of them. So that is resistant to failure across one of those, in our case, 20 nodes. In the next year, our plan is to move from those 20 validators, all controlled by OTF, to a number of different organizations inside of the ecosystem that can carefully protect those nodes and keep them up. Spread the load, the computational load, but also the regulatory risk and defense against exterior actors. We're going to do this slowly, but the end goal is to move completely away from proof of authority nodes, where there's just a fixed set of keys that can run the chains, to one that is proof of stake entirely. So that process is something that we know how to do. We've actually done it before. We actually have run proof of stake version of BitTensor internal to OTF, and we simply have been postponing that level of decentralization to get to a point where we're sure everything is running smoothly and we can move fast and break things, but still know that we're going in the right direction towards more decentralization. Okay, but what happened? I think people are pretty interested in hearing what happened 2 days ago. So there, at around, I think my time, 1 a.m., the chain simply halted, stopped finalizing blocks. And there's a lot of reasons that can happen on a chain. Um, but the gist of it is that the validator nodes are incapable of reaching consensus about the state. Something's going on when they're finalizing blocks, and we couldn't see what that was. We were actually blind to uh, the failure that occurred in our validator nodes. We didn't have the logs. Unfortunately, we can't trace everything because the logs size would just be too massive. And even when we turned on trace logging, we couldn't see an error uh, in the block transition function. We could not debug it in finalization of the validator nodes. And we were pretty stumped all of not last night, but the night before, figuring out what the hell happened. So a lot of our developers ended up staying up until the wee hours of the morning, debugging, keeping the chain finalizing, and then it would break when we connected it back to the network. We couldn't figure out what's going on. Um, the following morning, we began investigating uh, deeper into the block transition functions, the grandpa palettes, the finality of the substrate chain. And an anonymous person reached out to us asking for a bounty. They said they had some information for us about the chain and why it had gone down. Usually, this is a scam. People, when they reach out to us online and say, "Hey, like we fixed something," or you know, there's an issue with your email or your website, like often these approaches are a form of scam operation where they're going to try to uh, get you to pay for something that's not legitimate, or like they've actually attacked you in the first place and are now looking for a reward for your data. It's very common in our position, so we were very skeptical at first, but after speaking with this individual who I won't name, we realized that they actually had some legitimate information for us. They had discovered a pretty serious issue with the way in which transactions were validated on our chain. And I'm not going to say much about uh, that vulnerability because we think it would be irresponsible of us to talk about it because it's not currently patched entirely across the ecosystem. But the gist of it was that it was possible for people to create transactions that could create this sort of loss of consensus on BitTensor and beyond. Thankfully, we ended up paying this bounty and getting this information, and we're able to patch a fix um, late last night. We patched the fix deep inside the substrate code base and went to launch the network last night. We thought we'd be able to get it up within 24 hours of the chain going down. Unfortunately, the there was a bit of like a poisoning throughout the network, and everyone's nodes online across the entire network were broadcasting um, blocks and finalization rounds that we couldn't get rid of. And these rounds, these consensus rounds, were properly signed and would enter into our walled off network and basically poison all of our nodes continuously. So this was very serious because nothing was at risk in terms of losing state or people accessing the nodes, but it was just not possible for us to get the chain finalizing again. uh, this is a very difficult thing for us to fix because BitTensor is built on a stack that we don't fully have control of. So we build on Substrate, and Substrate is maintained by Polkadot, the Polkadot SDK, and not all of that is underneath our control. So it wasn't possible for us to go down to the level that we needed to fix it um, very easily. Very heavy lift for us. Anyways, I want to just call out some of the developers at OTF that managed to fix this issue. Specifically, Voon from Latent and Jip from OTF, the heads of respective nucleus and medulla teams at OTF that worked really like 48 hours straight, fixing this, hardly sleeping at all. And we were able to bring in the code into the subtensor code base that allowed us to fix this issue, and basically fork the network, a soft fork, but sort of a manual soft fork underneath, and bring everything back into consensus. So, wow, we were really biting our nails all the way up until Novelty Search. We didn't know if we'd be able to get it done. Sort of like people were asking for ETAs, and we didn't have anything we could say, because when you're working with that much complexity, especially in a complex like multi-nodal network, it's difficult to know what's going to happen. There's a lot of moving parts. But we've been here so many times. We have been struggling since the very beginning with Substrate making this thing work and keeping ourselves aligned with the decentralized future, even though it's very difficult to use. We got it working, and everything is now working perfectly fine as far as I know. There's no issues on the chain. Right, Ella? I think we're finalizing block perfectly.
Looks good.
Yeah, totally fantastic. So because of that, because of the great work from developers at OTF and Latent, we get to interview this amazing team today on Novelty Search. We have Mog Machine, thankfully, up on stage with us, and the rest of the Vidaio team. Did I say that right? Is it video?
It is.
Vidaio.
It's video. You just
Vid-
say video the way you would have said it normally, and then you spell it incorrectly with an AI in it. I think that's what we've decided. After the popularity of what was Bit API, I had nothing to do with the naming of this. I let the team take full responsibility. However, I have come to accept and love that it's just video.
You did
Video.
warn me about it, but yeah, video.
Yeah, there you go. So I will very quickly just take a moment to introduce this team and then step back, because other than providing the legs for this team to get going, the running, the hard work, and the graft has been all theirs. I actually know Gareth from real life, and I believe I accidentally probably told him about BitTensor over a glass of wine or a game of paddle, and we hadn't spoken in about 6 months, and he messaged me one day, so I've got something to speak to you about. And I thought, what's going on here? What are we going to do? I thought it was a party, maybe. And it was the one person in the world who I didn't expect to say, I have an idea for a subnet. It's obviously a message I get quite often. And then proceeded to give me one of the best business plans and briefs that I've seen for a subnet. So it made me sit up and take stock, knowing what I know about him and his professional background and expertise. And I decided it was definitely worth it for the benefit of the network. I felt like in order to get some subnets launched under detail, we had to be in the trenches and understand how it works. It was no good giving advice to future builders, developers, business owners about something that I hadn't really experienced and been through myself. It's been an experience. The team have really shone, and I think I'm going to hand over to Gareth and the team in order to kick this presentation off, and just come back a little bit later to talk about some of the parts that involved me a bit more deeply. So over to you, Gareth.
Oh, hello. Thank you for that, Mog. Hi, everyone. Let me get my screen up. Okay. Can everyone see that?
Not
Not
yet.
yet. It's Discord. So it was what we literally did we did a rehearsal of this half an hour before this call, and it worked.
God, whose
Failed
idea was it to set up Discord for BitTensor anyway?
It was my idea.
I could see it for a second, and then it's gone.
Shall I try again?
Yeah, cancel and try again.
Let's put it in firewall. I actually recommend Colden's comment here. Just paste screenshots. It's good. When we do the video recording, we just put them on screen.
Drop the PDF in there, by all means, Gareth. But this one,
Okay.
it's incredibly shit. Drop the PDF in there, and I'll see if I can do it.
Yeah, give me 1 minute. This is a good start.
So much rehearsals.
We can always try your screen log. It might work better.
Yeah, that's exactly.
It tends to be because there's not a good connection between the host and the server.
So Mog, just send that to you.
Yeah, I've got it. I'm just opening it now. It's just downloading. You need to compress that PDF. So, right, let me share my screen. You see that?
Fantastic. We can see that, Mog.
Good.
There we go.
Beautiful.
You just call next, Gareth, when you need it. Let's see if I can go to full
Okay,
screen. Can you see full screen?
Full screen looks good.
Good.
I would say next. Okay, so here's a little rundown of what we're going to go through. I'm not going to read out every item, but just to give you a little idea, the first part of the presentation, we're just going to set the scene, talk about the problem, why we came about, why we thought it was a good idea, obviously what we're doing, what video processing is, introduce the team, then we'll have a bit of a deeper dive into video compression, the upscaling and the subnet performance so far. Then the last part would talk about the future collaborations and our strategy for the market. Next slide, please. So let's talk about the problem. So if you look at the statistic on screen, we've got 85% of traffic on the internet is video based. So if we think about the scale of this, every single one of those videos, every single piece of content that goes live on screen has to be processed in some way. So whether it's upscaled, whether it's downscaled, whether it's compressed, all of these things have to be done before it gets to your screen. So there's many different ways to do video processing. We're just concentrating on a couple of these things, but we plan to add a lot more, into the subnet as we go along. Okay, next slide, thanks. So the problem is the problem that streaming platforms and content owners are facing is that they have spiraling costs. All of their delivery and storage costs are out of control. More content is being added onto CDNs, onto storage systems, onto platforms every day. It's not being deleted. It's just getting more and more and more. So the costs are getting out of control. No one's really looking at a way to address these costs. No one's using any platforms or any products to kind of address the problems that these guys are facing, which is essentially too much content, too much storage, and the costs are too high. So if we could, next slide, please, mate. So the solution. And again, yes. Vidaio, which is our subnet on subnet 85 on a bit tensor network. So we've been going for just over a month now. We launched on the 17th of April. We've had, amazing success. We've had really great feedback from the community, which is hugely appreciated. And also, we're super pleased with the way our output's going and all of our miners and how the output is moving forward. So thank you. So yes, so things that we are looking at is AI-driven video upscaling and AI-driven video compression. So upscaling, I think, is fairly obvious. We take a low resolution piece of content and we upscale it from, say, SD to HD or 4K. And compression, essentially, we're reducing the size of a file without compromising the quality, so it's easier to store and play. Next slide. So yeah, just for a little summary, we're built for content owners, platforms, and developers who need the high quality processing, and they without the centralized cost and control. So a lot of this centralized problem, the problem with the centralized industry is that it's very closed off, it's very slow to innovate, and it's really expensive to use. So what is video processing, the rather generic term of video processing? So that obviously can mean anything that you do to a video from when it's been shot on the camera to when it goes to be played on your screen. So it touches many different industries, obviously not just content and broadcast. There's a lot of other industries that use video. So yeah, so the video processing essentially is just what we do to a video from between when it gets filmed to when it gets on your screen. So we're focusing on two core areas, which we touched upon before, the upscaling and the video compression. We're going to take a much deeper dive into these when we kind of go into the subnet and how we use our incentive mechanisms. So why now, and why are we building on BitTensor? So in all honesty, that we couldn't find a decent solution for video upscaling or video compression that's out on the market. There are companies that are doing this, but they are huge enterprise companies or companies doing it at a much smaller scale, but they don't have a decent viable product. So, you know, we really saw that there was a big gap in the market for a decent product that could address these problems. So that's why we started our BitTensor subnet. So yeah, so essentially we're building what the market needs. There's a huge gap in the market. There's a massive scope for so many different industries, so many different areas, so many different people to use our products. We're going to showcase you our video compression model shortly, and what we're doing is completely groundbreaking, and it's essentially something that isn't seen anywhere in the industry. So it's super exciting, and I'm very excited for you guys to see it. So yeah, this is the team. So give you a bit of background on myself. I am not from an AI or crypto background at all. I come from more of a product and operations side. So please forgive me later on if I can't answer some of the deeper technical questions. I'm learning every day and I'm doing my best. I've worked with some of the major players in the industry: Netflix, Disney, Sony, Spotify, Hulu. I've even worked at Pokemon and a few other places that I'm sure you've heard of. So yeah, I've got huge industry experience. I really understand the market, and I've got 20 years worth of network that I'm going to call upon to take this product to market. So next in the line, we've got Ahmed, who's our machine learning engineer. He's working predominantly on our compression model, and he's going to showcase that today. And it really is quite amazing what he's managed to achieve in a very short time. So yeah, I'm super excited for everyone to see that. He has a PhD in distributed learning, and he's been with us for, I think, about 8 months now, from when we started the company. So next we have Mog, who I don't think I need to give an introduction to. We have Gopi, who's actually traveling today, so he couldn't be here, but he is our video technology expert. So he's been working with computer vision and video compression for many years. Medville, who is on the chat for any technical questions. He is our subnet architect and incentive mechanism architect. And I think all of the miners and validators will know him quite well, as he's been Yeah, very active on the chat and getting everyone up to speed. And lastly, we've got Akin and Chinaza, who are our front end and product designers. They're responsible for our amazing website and of course this presentation today. So let's have a look at the addressable market. So we're looking at a $400 billion market across all of these different industries. I mean, obviously we're going to go for the first two markets first, which is the video streaming and the cloud storage and CDN providers. As you can see, that's 300 billion market in itself. It's a huge market and it's exponentially growing, and our tools are absolutely right for these guys to use, and they're going to make some huge cost savings. So if we're looking at, you know, the other three areas on this, all of these companies and industries are going to be able to use our tools. Obviously, post-production, AI-powered video tools, but surveillance and security and medical and industrial imaging. So if you think about the use cases for those, we can upscale bad quality content, we can help them with their storage, we can look after all the problems that they have. So let's get into video upscaling. So we have, at the moment, video upscaling is the only thing live on the network. We have compression coming very soon, but upscaling is what we're live with. It's still in beta, so we're still kind of testing and making sure everything works. But so far it's going very well. The workflow is fairly simple. We take a low resolution file and we send it out to the miners. We ask them to upscale it. They send it back to us, and then we verify that using a couple of different methods. So we've got the VMath method, which is actually the Netflix standard method, which was made by them. And then we also use PyApp. So the thing about video validation mechanisms is they have quite a lot of acronyms. So here are two of the more common ones we use. The reason we don't just use VMath is because when we were creating the incentive mechanism, we realized that it could be quite easily gamed. So we're just using that to make sure that the same file that was sent to the miner is returned. And then we use PyApp to calculate the score for the miner, and that's what we use to calculate their incentives. So also we have a no reference workflow. So this would be our organic workflow. So if someone's uploading a video through our front end, then we have a no reference workflow, meaning we don't have a file to reference to check the quality of the video against. So we use a different metric for that, which is called Clip IQA Plus, but it does a very similar thing. It's looking at the perceptual quality of the video. So the real important thing for us here is the perceptual quality. Traditional verification mechanisms will be using mathematical equations to check the quality of the video, but here we're looking for how it's perceived by the human eye. So we have machine learning models that have been trained on huge data sets to let us know, you know, how the video is to the human eye. Okay, so new features we've got coming soon for the app. These are, yeah.
Do you mind if I ask some questions? Are good. So
no, of course.
Tell me about upscaling. You know, when I'm watching a video on YouTube, there's like 4K. You're saying that you can make that video 8K?
Yeah, absolutely. And so, although 8K isn't live quite on the subnet yet, but yes, we can make your 4K video 8K. We can even go from HD to 8K.
And that's basically a generative model that's applied to the model, applied to the image. So you basically are taking like a 8x8 grid and adding more pixels and predicting the correct pixel values from the image. Is that basically how it works? Like a CNN?
No, that's exactly that. Yeah, exactly. So say we're 2x in the size of the video from 4K to 8K, perfect example. So then, yeah, we are using generative AI and the models to fill in the gaps basically. So it's going to know exactly what should be in the picture because of obviously the machine learning training. So yeah, that's exactly that.
And is that something that's being used like right now? Are we watching something that's being upscaled with vision models?
Yeah, totally. I mean, it's kind of in its infancy because it's obviously very data heavy and it needs to have such big data sets to learn from. But yes, essentially you are watching it, and you can be watching it, and you can actually upscale a video through our website if you so
What happens?
desire.
What happens if you just infinitely upscale? Like what comes out of? Just kidding. But where
Yeah,
is
no,
where is
I
yeah?
think there is a limit.
What is the most resolution that one can get out of an image? Uh, no, but seriously, like where is that being used in technologies that people in the audience might know?
So I guess an easier example would to be to look at a use case for it. So for instance, if you are a content owner with a back catalog of SD content, right? So I mean, like you say, there's limitations that we can't take it to the moon, but what we can do is we can take an SD file and turn it into HD or 4K. So that means that you can have this poor quality bit fuzzy file that now looks sharp, and it's totally fine to kind of play on your TV or on your tablet or on your phone. Whereas before you'd notice the quality that was bad. Now it's quality that's actually acceptable for kind of modern audiences.
Can I jump in with a real world example here? Because I have
Yeah,
one. So, someone like myself who grew up in the 90s has a shitload of skate movies that we all shot on SD, on old VHS, or not VHS, on the high 8, etc. If I wanted to include those into a little documentary that I was making, or you see it in many documentaries where they go back and take 90s footage or early 2000s footage, if you were to just take that footage, which is a much lower resolution, and say, well, I'm just going to stretch that up to the size of my HD or 4K output, what you would essentially be doing is growing the pixels, and it would look incredibly pixelated. So what's happening here is, as you say, it's analyzing the pixels and creating new pixels just to allow you to show that footage in a usable, watchable way. It's still, I would say, if you look at a 90s footage, it's not going to turn it into what you would expect to see as a demo for a Samsung 8K TV. It's not creating magic, but it's making that content that was previously not possible to be played at a higher resolution possible. And the difference with this is it's using perceptual quality. So rather than just using math to say, well, hey, let's look at all these pixels and double them and grow them, what it's actually doing is saying, well, hold on a minute, what matters to your human eye? Where are you going to notice a difference? Where is their motion? Where are their faces? And that's what AI is enabling it to do better. Because I came with this same question. I'm like, hold on a minute, there are codecs to do this already, but they're doing it from a very, very mathematical point of view. And the way that the AI models are working is to bring in perceptual quality into this.
At the beginning of the presentation, you said 80% of the internet traffic is streaming videos, which, by the way, is insane, right? It means that
yeah,
4 out of 5 bits that are transferred across the internet are for video. And
yeah.
and how many of those bits, or how much of that video is being upscaled continually?
So yeah, so I mean, it's not a huge percentage. The upscaling model isn't really the thing that we see the real value for the bits for the bit tensor subnet. Definitely, the video compression is really where I think the real business lies. So if you take the example you just said, so 85% of the content on the internet is video. So it's unnecessarily, like, if we can take that video and compress it to half the file size but at the same perceived quality, then you're looking at using less bandwidth, less storage, and the user still has exactly the same experience that it had in the beginning. So if you are a streaming platform, a VOD hosting platform, a CDN, or anyone who's storing content, if you use our compression model, which Ahmed's going to show you very shortly, where you can see we can get files up to 80% smaller for the same perceived quality. So if you think about the future of that, and how much cost saving that's going to give our clients, and there's going to be no detriment to the end user, I think this is going to be really, the biggest thing. The upscaling is great and it's nice to look at because you can take a blurry video and you can make it clear, but really the video compression is going to be something that's going to absolutely change the industry. No one here is doing anything like what we're doing, and it's pretty exciting to see. So I think the upscaling is more, there is a market for it, but the market will be like Mog's example is perfect, or if you have like a broadcaster in Brazil who has 10 years of telenovelas that they want to repurpose and put onto like a VOD platform, then we can go there, we can upscale it for them and they can put it on the platform. But the video compression model is really the one that is, we're really making some big boundaries with. So
if I can just jump in, from a business development point of view, pushing out the upscaling Synapse first was a better choice to build up relationships with the miners, get the subnet off the ground. It's a much easier one for mining teams to pick up on, to learn quickly, and has, I would say, less especially as you're upscaling poorer quality video, the sizes, so that it's just in order to get the subnet off the ground. Whereas if you go straight in there with compression, it was a bit of a slap in the face and quite a surprise, and I think it would have been harder to get the subnet from 0 to functional product within 30 days. And yeah, it required, I think, the compression, a lot more research and proprietary development from the team, which is why our upscaling has been pushed out first.
So with compression, Alan, please.
No, I have a quick question about the current slide you have here for the benchmarks. Maybe it's a little unrelated. Curious about the benchmark comparisons you've got there. How did you normalize those across these tools like Topaz, FFmpeg, HitPaw, and how basically are these metrics consistent across the different content types you have? Or just really curious about how you got those numbers.
Yeah, so this is part of the upscaling benchmarking. So what we did is we took the same file, we upscale it with all of those different companies, and then we used our own base miner code to do the same. We checked it with the quality metrics that we're using for our incentive mechanism, and then obviously ours came out on top. I mean, if you look at the closeness between that and Topaz, it's not huge, but this is our base miner model, which the miners have already massively improved on. So if we were to run these tests probably today, then I think we'd see a lot better results for us.
Wait, so you're saying that your upscaling is better than all 3 competitors in the same space?
Yes.
As
exactly
of today?
that, yeah.
And this is just your base miner?
Yeah. This is the base miner.
Can you help us interpret this metric? So 0.4697 is your score. I'm assuming that having higher score is better. What does that mean for a client in terms of their bottom line metrics? Does it mean they can compress more? Does it mean that the quality is better? What exactly does it mean?
This is perceptual visual quality. So this is how the file looks. So we benchmark that by taking all of the files and checking that our metrics work. So but what we're really measuring here for the upscaling is perceptual visual quality for sure. So it's how it looks to the human eye. So when you look at ours against the other 3, you should be able to see the difference. Ours should be clearer, ours should be sharper, the color should be better.
And speed is an aspect here, right? If I'm understanding correctly, like you are sending data through the mining network and doing this compression or upscaling, and if it's streaming, isn't latency a massive part of that, and in terms of like the experience for the user, or not at all? Like, is that not something that matters? And are you able to match these companies in terms of latency and bandwidth?
Yeah, so we're not directly streaming with the upscale. We're just taking a file and upscaling it and then redelivering it. So, you know, yeah. So we're actually comparable in speed to all three of these solutions.
Right.
So
Because
in fact,
because
it was much lower than we are.
it happens offline. It's not like an online processing that occurs.
Yeah.
Okay.
Exactly. So
Okay.
we have streaming in the roadmap for sure, but that's a very, very complicated issue. So, you know, that's going to take a lot of research and development, but it's definitely something we want to do. That like a decentralized streaming network on BitTensor, I think would be incredible.
I guess the other question.
Okay.
Sorry.
Yeah.
How are you guys dealing with privacy on these videos? Basically, if somebody was to upload like a sensitive video or anything like that, or maybe even videos that are, say, for example, CSAM content, yada yada, are you guys sort of dealing with that kind of filtering, or are you kind of keeping it encrypted, or anything of that sort yet?
Not yet. I mean, it's a very difficult thing to do because we obviously the miner has to see the video. So
right.
Currently, the way it works is we break the video up into 1 second chunks. We send it out to the miners, and they do the mining and send it back. So essentially, in theory, they would only have access to 1 second, or depending who they are and how many miners they're running, I suppose, of the video. But this is something really that we need to think about when we're moving on to bigger clients. For instance, if we're looking at sensitive content or unreleased content, we really need to be careful about the security behind that. So we're looking at some protocols and some ways of working, but we haven't really come up with a solution as yet for that.
I'm going to jump in, Shib, because I think Gareth skipped or missed the CSAM reference. At the moment, there isn't shall we say, porn, nudity, or inappropriate content filter on the upscaling. As I said, it's in beta for the last 7 days, but there absolutely will be. These are very easy machine learning models to essentially not allow any form of porn or nudity. I know it's going to be a difficult one, but the usage for porn, actually for prominent issues.
Like that.
Yeah, totally. And I think, you know, we
to be an anonymous decentralized service, although there's no payments in place yet. So yeah, there will be some accountability.
Makes sense. Thanks, guys.
Should we get?
Yeah, let's go. Let's
Ahmed,
get to the video compression model. So Ahmed's going to showcase the model that he's been working on. He's got a proof of concept app to show you.
You want to try and share your screen, Ahmed? See if yours works, so you can jump in and control your screen.
Yeah, I'll try, but I think the button to share my screen is kind of deactivated right now. So I think one needs to stop streaming so I can maybe.
Can we give
yeah.
Ahmed
Let me try.
permission?
Let me try now, please. Okay, can you guys see my screen now?
Give us a yes, but we can see Discord.
All right, perfect. Yeah,
Got it. Perfect.
All right, so yeah, guys, we'll be first. Yeah, hi everyone. My name is Ahmad, and I'm a machine learning engineer at Vidaio. And I'm really excited. I've been working in the last couple of months on a really cool project, which is the video compression algorithm. Basically, what we are trying to achieve here is we try. Um, Basically, nowadays, almost all the videos that you see online are kind of somehow encoded. Because in every video there's a lot of redundancies that usually could be encoded really efficiently. So a video that is like 1 GB will end up being like 10 megabits or something like this with by encoding this kind of like redundancy. But the issue or the thing that we're trying here to solve is that usually in terms of like in the encoder space right now, there's a one solution fit all kind of thing. So for example, you have an H.264 encoder that uses the default settings and is being applied on every single video. And that would kind of lead to suboptimal encoding in that space. So basically, you could basically push the encryption or push the compression even more without losing much quality by kind of optimizing those encoder parameters. And that's exactly what we're trying to do here. Basically, there is no solution out there that does what we're doing in a open source and a readily available way. What we do is basically we develop a couple of machine learning models that analyze the content at hand, and then it tries to predict or tries to output the best parameters that we could feed into the encoder, telling them what is the content at hand, what is the best way to encode that video in giving the best efficiency possible. So yeah, this is basically what we're trying to do. Also, we apply pre-processing steps on the video to try to get rid of some of the artifacts that come with a lot of online videos, like noise, blurring, blocking, and banding. So we try to get rid of those before we do the encoding so that we increase the visual or the like the visual quality of the video even before it degrades naturally because of the compression. So we end up by basically preserving the texture and visual sharpness with high compression levels. Basically, how we do that, I'm going to go a little bit into details here. Basically, we start with the full video that the user uploads. That video will get basically distributed between the miners, but let's assume here it's centralized. So we have the full video. That video will be pre-processed, as we've said, to get rid of the artifacts that come with the video and increase the visual quality. After that, the video will be split into couple onto scenes. And the idea behind this, imagine if we have a movie, the movie have like different scenes in it. And a lot of scenes, some of the scenes are static, so no dynamic, no motion happening in them, not money, like not much motion. And some of the scenes in the video are like, for example, action scenes or something like this. There's high motion. And those different scenes could be encoded differently. And by analyzing or by splitting those scenes, we can ensure that each scene will get encoded in the best efficiency or the best way possible. Now, every scene will be analyzed to basically know or infer some video metrics about it. And those video metrics will tell us, for example, how complex the textures in the scene are, how complex the motion is, and how much contrast in the video is, and so on. And also, the video will be like we'll extract a couple of frames off from it. And here, those frames are going to be classified using our developed model in order to identify what type of scene are we dealing with. So, for example, if we have if we have people talking in a scene, so like people's faces, so these are should be treated differently than, for example, if we have nature scenes, and those should be treated differently if we have like gaming or animation videos where basically the texture quality is not as important, for example, in the encoder as like nature, for example. And those two information will be input into another also model that we developed, basically that takes this information as an input, and also takes as an input the defined user, like the desired output quality defined by the user. So for example, a user want the best quality possible, so they define a certain, like they define that, they tell us that, and then our model will take all of these information, and then it will give us the best encoder parameters that we can apply. And we use already like widely supported, widely used encoders from H.264, which is considered now widely supported, but also a little bit old, and newer encoders like HEVC or AV1 encoder.
Why
And
not,
after,
Ahmad? Why
sorry,
not just learn that entire thing? Why not just use neural networks to extract the frame scene by scene, classify the frames, optimize the encoding parameters? Why is that not just a feed forward neural network
so
problem?
now it's a very interesting question, but now we fall into the problem of compatibility. So if you compress, the idea is you want a source that decodes or encodes the video in a certain way, in a certain bitrate way, and a source also, or the target, that basically takes that information and knows how to decode it in a way that reconstruct the original video in the best way possible. And here comes the compatibility issue. If you use a machine learning model, unless the user that plays the video has this exact same machine learning model, for example, if you're using an encoder decoder model, if like the user doesn't have that exact same decoder to decode the certain stream that you used, they won't be able to reconstruct the video. So they have to have that machine learning model also available at every user who wants to view the video. Also, that's one thing. So the compatibility issue. Second of all, you need a huge amount of videos and data in order to train machine learning models to encode videos end to end. I've experimented with this for like a couple of months, actually, tried to analyze all the models in the literature that tries to do this thing, and none of them actually are kind of one solution fit all kind of problem. They usually present them in literature on a certain database, and when you try to apply them on a different database, they perform horribly because they basically haven't been trained on um, a wide variety of available videos. So that's also an issue. Third, we come also into the problem of, not the problem, but the modern video encoders that we have these days, like AV1 or HEVC, or the H.266, basically the new one, the new AVC, I think it's called, like the short for it. Those encoders are really good right now in terms of analyzing, or like being a one solution fit all kind of encoders. So they work really, really well. And in order to have a machine learning model that competes and defeats this model, it's basically, I don't think that will happen in the next like couple of years, especially with the current limitation that we have with the availability of enough video training data for the videos, for sorry, the machine learning encoder.
That makes sense. So you can't transmit the neural network to all of the downstream devices, and so you can't. You would have to pass like a couple gigabytes to have the actual model on the other side to do the decompression. Is what you're saying?
Yeah. Every user device that wants to view the video need to have the machine learning model in order to be able to view the video, and that's a
Interesting.
compatibility issue. So unless you have control over the software, hardware, kind of cycle for every end user, you like it's really hard to have that. And that's very
What
different
do you
in terms of the
what
encoders themselves.
what do all clients have that you can use? I guess they have access to the encoders that you're using. That's like
So
standard
here,
across
here
all.
we are using widely available encoders. What we do is we optimize the parameters of those encoders. So for example, if you have an encoder with the default settings like H.264, and you try to encode a video, you will have certain like compression rate, for example. Let's assume it's 10 or 20%. So the output video is 20% the input video size. But what we do is by analyzing the video at hand, and especially if it's a long video where there are different scenes with different dynamics in every scene, what we do is we optimize the parameters for each of those scenes so that the encoding processes happen in a much more efficient way. That we have a smaller video with the same perceptual, like visual perception, basically.
And what we're looking at here on the screen, this is the
Sorry.
is this the base miner?
Sorry, is this what?
Is this the base miner, or in the sense that like can the miners tweak these parameters and try to
No, no,
beat?
no, no. The miner will have our engine, so the compression engine, and this pipeline will happen at each of the miners, basically hardware. So every miner will have, for example, a 1 second video, a 1 second segment of the video. And then that second will be, for example, analyzed. uh, some frames will be extracted, and will have the metrics, we will have the frames. Those will be turned here into classified into the scene. So we know what is the type of the scene. And this information will be used to basically optimize the encoder parameters, and then that 1 second segment will be encoded, and then we will have a 1 second segment that we ensure that is encoded to the best efficiency possible.
Why don't you show him?
Yeah, I will definitely show it now. So we also have a proof of concept app to show here. It's very like early stages, but it's just to show how is very simple, like simply how the algorithm would work. So here our engine supports both uncompressed videos and compressed videos. Of course, if the imported video is uncompressed, then the compression will have much more um, like efficiency, because it has much more data to work with in order to encode the video. So here, for example, we'll just like, for example, choose a video. We've chosen here one uncompressed video. We cannot view it here because it's most of the browsers do not support playing uncompressed videos. But here, the video, like the pipeline will still work. We would choose what target VMAF score we want to have. For example, a video, we want high quality score videos, so we choose like VMAF score of 96, for example. And then here we have every miner can choose what codec they want to, sorry, the user will choose what like the codec they want to have to encode their video. There are some hardware accelerated codecs, and there are software like software um, um, encoders, or they can choose auto. And by choosing auto, our engine itself will figure out what every miner's hardware, what is the best supported codec, and then it will encode the video using that codec. Also, we can choose to either like calculate the VMAF score of the output video or not. But here, yeah, we can press on encoding the video. The pipeline will start encoding the video. Here we can see that the algorithm figures out that AV1, the hardware accelerated version of it, the NVIDIA encoder, is supported by like at my PC, and then it uses that. We can see how it's really fast, the video encoder, and we can see here's the output video. Like we can see the playback, but here we can see some stats about the encoding process itself. So the original video was almost 800 megabytes, and the encoded file size is almost 40 megabytes. And by doing like with our compression, we reduced the file size by almost 750 megabytes. And that gave us a compression rate of 4.8%. So the output video is only 4.8% the size of the original video. We can also see how is the input bitrate. This is much higher than a lot of people's internet would support. So we can see why for like internet playback, we never play uncompressed videos. And we can see that after the compression now, the bitrate for that video is 32 megabits per second, which is doable by a lot of people's like available internet right now. We can also see that our algorithm predicted that the scene at hand has faces and people in it, which is basically what we have here. We can also, just to see how also our algorithm can work on compressed videos. So this is a video that is already being encoded, but we want to do something we call transcoding. So we want to encode it again with our algorithm. And we can see here that if we press also in encoding, we can encode it. This will take also like around 10 seconds. This is also like these 10 seconds include all of our pipeline in terms of like analyzing the scenes, splitting the scenes, having the machine learning model to like predict the best parameters and like classify the scenes. And here we can see also the output with very good also output quality. And we can see here that the compression rate, because it's already compressed the video, the efficiency of the transcoding is less, definitely, but it's still like we reduced the original file size from 230 megabytes to 67.9 megabytes. So yeah, this is an example of how our like compression algorithm works and how fast and how efficient it would produce output files for the community. So yeah, that's
So
it from my side.
it's quite incredible, the technology that you guys have brought to BitTensor. What is the dimension along which the miners are actually competing? Is it the number of videos they can use that they can compress in a particular moment of time? You said they're not able to tweak this algorithm. So is it just compute scale that they're bringing? Can you talk more about where the optimization is occurring in the network itself?
I mean, in terms of the network, I'm not the right guy to be asked about that.
Yeah, I can
I'm
answer.
mainly, yeah, I'm mainly
So,
focused on the machine learning part of the network, but yeah, I'm
so
sure
yeah.
like
So to answer your question, Constance, it's like this isn't actually live. It's not live on the subnet yet. So we've only got the upscaling live. So this is still in the proof of concept stage. So essentially, we've already, as you can see, got an incredible model for the miners to start using. If they can improve on that, great. I mean, we'll give them the opportunity for sure. Also, yeah, I think if we're looking at big uncompressed files, we're going to have the metrics we're going to be looking at. Of course, is going to be we need to have that perceived quality high score. We need to be compressed as much as possible, but we're going to be looking at definitely we're going to be looking at speed. So that's going to be like compute power as well. So they're the metrics that I think we're going to design the mechanism around.
So
Yeah, I think
the Pi app score was the one that measured the performance of the compression, correct? Or
no.
the
So
upscaling?
the current live Synapse is upscaling, which
Yep.
is the one that miners are competing and improving on the base model, and have taken it past what was pushed out by the subnet, and you can actually see this was skipped out from the previous slides. The week-on-week performance in increase in VMAF score and decrease in PIAP. PIAP is better the lower it is, and VMAF is better the higher it is. But the video compression that you've just seen is a proof of concept of the actual workflow. So as in so many things within BitTensor, look at a workflow and then define how you can incentivize optimization of it. But because this workflow doesn't technically exist, and it's a novel new workflow created to be deployed on BitTensor, the incentive aspect is not fully nailed down in terms of how miners will compete in terms of optimizing that, be it speed, be it volume, be it in increasing the compression ability, the compression rate versus quality. So the actual incentive aspect of the compression is not written and deployed yet.
So what are we looking at here on the screen with the VMath score and the PIAP score? I know you mentioned this before, but like these are the results coming from the miners. This is what they've been optimizing.
Yeah, if you look at the birth of the subnet, so the first week, this was primarily people using the base model, as with most BitTensor subnets. Everyone deploys the base model. Then you have a very small period where everyone tries to game the hell out of it. And then very fortunately, what's happened here has sprung up a couple of teams of miners who have specifically dedicated themselves to this, either brought in external knowledge or gone out and armed themselves with knowledge and put some teams together. And the subnet itself has now actually made good personal contact with these miners, something of which the value I'll speak about in a bit, so that these miners are devoting a large amount of their time to improving and actually caring about the subnet itself. Something very similar that happened with 19. I know it's happened with shoots. Once you get, and I know you've spoken about it, miners that genuinely care about the product of the subnet and are vested in the subnet, and then also if you get more than one of those teams, you still have that organic competition, and the subnet starts to exponentially improve. And that's what we're looking at here. The proof of the improvement, even over 4 weeks.
So how are they doing this? Like the VMAP score and the PIAP score. Like, take us through a bit of like
I'd love to get a miner on stage and have them tell us that, but they're not going to tell us, are they? Gopi would be the one to discuss this with, because and if you look through the subnet channel and some of the research, when I follow the internal discussions, there are metrics and ways. I don't know, Gareth, if Gareth or potentially Medfill in the chat, if you want to outline how the miners are approaching the improvement without maybe giving away their secret sauce.
Yeah, sure. I mean, they're tweaking the models. We're using some open source models, and there are other tweaks you can do. I mean, as you saw, our managers managed to create an amazing workflow, and I think some of the miners are looking at things outside of what we put in the base model to do that. We're also actively checking that they're not just gaming the subnet, so we're making sure that we're benchmarking the quality, that the perceived quality is what it's supposed to be. So like as we discussed earlier, VMAF, which is kind of the granddaddy of video quality metrics, is great in a non-incentivized environment, but in this environment it's too easily gamed, so we only use it for some very basic checks. So yeah, so they're using different tools that are available to make the upscale better and better, and we're not 100% sure what we're doing, but
what they're doing.
Yeah, they're doing it well.
I mean,
what they're doing, not what we're doing. Well,
I mean, this is like the classic phenomenon of subnets on BitTensor, where you're like, so how did you achieve this? And the owners are like, we have no idea. It simply is occurring.
Yeah.
And so you guys have structured the incentive so that you're basically asking the miners to improve performance on their ability to upscale according to certain metrics. Are those metrics that you're using to measure this upscaling, are they legitimate, or are they just kind of contrived benchmarks?
No,
or are they standard like industry wide?
Yeah, they're totally standard industry metrics. Yeah, they're and so yeah, so we totally stand by that. We do our benchmarking, and yeah, they're out there being used by all of the companies in the space. So it's not something that we've made up. Yeah, it's definitely industry standard.
And the interesting thing is, if you actually go and browse through the last few weeks in the video channel in BitTensor Discord, you'll see a lot of miners arguing back and forward about modifications to the incentive mechanism, because, of course, as we all know, launching a subnet the first couple of weeks can be spicy. And you see that the miners are arguing back and forward, and the prevailing miners seem to be those that are orientating towards the betterment of the product and the subnet itself, and this is, as I say, only towards the upscaling at the moment, but really kind of positioning themselves to prioritize the subnet and its organic usage and ability to be used as a product versus just their ability to gain incentive. Of course, you can also see that other side being argued, but those are the ones that have clearly shown themselves and been pulled aside to work in sort of more closed private focus groups to improve the mechanisms further.
So Mog, you've been here for a long time, I think.
Yep, long enough.
Right. And one of the things, look at it even says Mog on the screen.
Mm-hmm.
So subnets on BitTensor, tend to have problems optimizing multiple dimensions, and this is one of the reasons why we need to have multi subnets or sub subnets in BitTensor specifically, so a team like this can focus on, say, optimizing performance and then optimizing, say, like bandwidth or scaling. Um, you guys want to serve compression for 80% of internet traffic. Is that something that is part of the design here, that where you're actually taking advantage of the distributed nature of this computing problem? As I understand it, like it's a fully decentralized computing problem. Like there's no need for interaction between the GPUs when they need to share state, like in a training algorithm. So what this is potentially like a perfect application of decentralized computing. Is that an aspect of the incentive where you want the miners to go out and pool like thousands of GPUs and computers together to scale this infrastructure?
I'll tell you what, give me this slide first, as it seems to be the first one there, and then I'll get to that one when I'll talk about it. Because we wanted to talk a little bit about the funding of the subnet and its structure, and then its perspectives and possibilities towards building these relationships that you speak about, where the miners are going. So yeah, let me skip to this one as quickly as I can, just for full transparency and where I fit in. Obviously, this subnet was incubated by Talstats, that means we paid the bills, and as with so many things that we do, I've taken a business first approach, which means launching it as one would a traditional business, but built on this new infrastructure that is the BitTensor network. But we have made sure that we keep that business approach. So we have open accountability for operations, for costs. At the moment, the subnet is funded, but it will be self-sustaining. It could be self-sustaining, but I have a mantra that you don't sell any alpha for 90 days. But I do believe that after 90 to 100 days, a quality subnet should be able to sustain its operational costs through open accounting and open accountability for operations. And it's something that you will see in the coming months or so. And also, obviously, the priority in this was to set a benchmark for what I expect from a subnet. I see so many subnet pitches, and I see so many subnets go live. I'm mean to so many subnets, and I really feel like I had to put my not my money where my mouth is, but had to say, look, you need to launch a subnet with a front end. You need to get your product to market as quickly as possible, especially in a detail world, and you watch the ebbs and flows of hype and speculation and interest in product. So this is really something that we try to do. And I feel it's been so far very successful. Of course, the reality is no one launches a tech startup in 30 days to the public, but that's really where we're going. Which then brings us on to the next point, which is, what are you doing? I'm surprised no one's asked it yet, which is, what's going on with revenue, what's going on with alpha value, and where are you taking this? And of course, the priority of any business is on before revenue, and I've seen a little Silicon Valley reference in there. It's revenue. You don't want revenue. We want to secure a solid customer base. through solid services. And then that's got to be the priority, because if you get that right, the revenue flows, and you're able to make better choices with how you stream that revenue. And so the first person you need to look after are the miners, because they are your contracting suppliers. And I firmly believe this, that the future, and I know you've spoken of it, I know it's shown such strong positive signals for shoots, for Targon, these strong subnets, and most of the strong subnets will say that their relationship with their miners is fundamental to their success. So they should be treated as such. No longer do we say fluff the miners. We actually want to build relationships with those miners, because those miners are the core suppliers and contractors of our business. And along that route, alpha is but one metric to include in ranking. And when I talk about ranking, at end games, in private chats, conversations, incubation conversations I'm having with people and listening to other people's subnet, I'm very, very interested in the different novel ways people have for revenue structure and value the direction back into alpha. And I'm listening, and I haven't come up, and I don't think anyone's come up with a steadfast, fixed plan that says this is the way we should be doing it. But I do believe that miner reputation is going to be paramount moving forward, and not just who holds the most alpha, or who's been doing the job the longest, or who did. There are a series of metrics in the same way you build a scoring mechanism, an incentive mechanism to assign value to miners. There must also be a mechanism designed to show the longevity value of miners, in terms of let's throw jobs out to the top 20. What is that top 20? It's easy to order by incentive, but I do believe you have to do more. And I do believe, and I'm not sure if this will be too popular at this stage, I haven't thrown this out into the public, but fuck it, it's in the slide. You need to not be afraid to foster business-to-business relationships. It's something that subnets may have to accept. So it comes back to an earlier point that we were speaking about, well, what do you do when you need to sign an NDA? Along comes Netflix, and they say, we've got this documentary, it's got a whole bunch of footage of Justin Bieber as a kid on VHS, and we need to upscale it, and you're the most optimum supplier to do this, but we can't put it through your open network. I'm sorry. We should be able to instantly know and incentivize miners to want to come forward and work within these business-to-business relationships. Obviously, knowing that our prime goal is to drive value back into the subnet and foster these relationships, and make sure that in order to earn these contracts and earn these positions for these business contracts, you still need to continue to perform within the subnet. Now, this is not a plan set in stone. This is an evolving plan. But I feel with the right kind of balance, this could be very, very successful in attracting revenue flow beyond the subnet itself. So a subnet becomes a part of a business, but not necessarily the entirety of it. I'm really open to listening to feedback and criticism on this more than anything, because I think it's something that needs to be hashed out. And when I've spoken to with other subnets, they are interested, but we tread this path with trepidation. Trust has to be earned, not assumed, I believe, from miners. And
Mark,
also, yes, tell me.
Mark, tell us. I think that of the personalities inside BitTensor that has had a lot of say, as well as influence on the way in which subnets should be built. Why do you think, like, threading the full path from subnet to customer is so important?
Because you literally lead me on to my next sentence. Because a subnet is a company or infrastructure that cannot be solely emissions dependent. You want to, or the network wants to grow to thousands of subnets. We can't sit there and think that emissions are going to be a free runway into the future to fund these businesses. I firmly believe that emissions will be very, very fluid into the future, where they may flow into subnets for short periods of time to spearhead initiatives. At the moment, we see that more based on hype and speculation in the early days. But I feel like, a subnet may be able to say, hey, look, we want to do this. We could do with some backing, and if we manage to make it work, there's going to be value in it for some emissions. But if you are sitting there building a subnet thinking this is going to work because we're going to get emissions, and that's your long-term plan, you're missing something. Now, okay, that is, of course, from my perspective as someone who's very product focused. A lot of subnets that I'm thinking about are end up with a product, end up with revenue, end up with a service. I'm not speaking on behalf of research subnets, and I'd say on behalf of things like Templar, sorry, not Templar, Templar, subnet 3. Yeah, it's Templar, isn't it? Subnets that potentially are outside the scope of my understanding in how they will push forward AI ML, and there are use cases outside of this. So I do speak within what I feel comfortable, but I do firmly believe that when you're building a company, you cannot be sitting there relying on emissions alone. They're fantastic to have, but they should not be the be all and end all.
I also think that it should be said that for a certain type of subnet, not all, and it's good that you pointed to some research subnets which have a different trajectory, but something like maybe this subnet, it's very clear where the market exists and how you can capture it. It makes sense to go all the way to the customer and build that stream, so that you know whether or not your product actually has market fit as soon as possible, right? So like I appreciate like the obviousness of the market here, and to go into that a little bit, who pays for this at the end of the day? Is it me as somebody who wants to compress or upscale images or videos, or is it large companies like Google that need extreme amounts of compression to happen on the fly?
I believe, in the same way who pays OpenAI's bills, you might pay your $9.99 GPT subscription per month, and that may make up 80% of the volume of their customer base, but that other 20% makes up 80% of the revenue, which is the business to business. So whilst there will be a subnet-based product for consumers that will be, I wouldn't say subsidized, but will not be there looking to make the maximum profit off you and more to offer you a service, the real value will come from business to business clients. Whether they can operate through the subnet infrastructure because privacy is not an issue, or whether they can secure a premium contract to work through the operatives or alongside the operatives of the subnet. So, I mean, I believe this is probably Gareth's speciality and the point that I should go back to him. But when we talk about the customer base, we are talking those that are operating at scale.
Yeah, totally. We're looking at big enterprise clients, content owners, CDN providers, VOD platforms, or anyone that's storing video data. We can cut your cost by 80% on storage, and the bandwidth you have to pay to stream the content out to your clients, then they're the people that are really going to use the service. The video upscaling tool is very nice. The video compression tool, via the website. If you're making a documentary and you need a little bit of content for, to fit into what you're doing, then it's a great tool for that. But we're going to be partnering with some enterprise clients, some big companies with huge archives. They're the people that will be giving the company profit.
You're unlikely to compress your next YouTube video before you upload it to YouTube because YouTube takes care of that. That said, if you did have a 200 megabyte video of you doing a lap around a track that you wanted to share with your friends, and WhatsApp said, sorry, that's too big to upload, must be below 100 meg, then you quite likely would fire up video, drop it in there, grab yourself a 10 meg version. I mean, if I do that myself, now I have to open up Handbrake, which is a very old utility I've been using for ages. I'm sure everyone has their little utility that they use to quickly compress a video, but there's no reason why video shouldn't also be one of those.
Also, Handbrake will not give you the perceived quality that we can give you.
Handbrake's wicked, man. Shut up.
Not down on Handbrake, but they're not using AI.
I haven't updated it since 1995. Very quickly, as I come out, and I'll hand back to Gareth on the collaborations. Of course, we can't forget where we are and where we're from and what got us here. So we are also, or the subnet itself is very big on collaborations within the subnet space, even in this very short period of time. Very soon, all of the subnet storage will be on Hippias rather than the current AWS solution. Bitmind is currently actively being incorporated, so you can tell, all right, you might be able to upload porn, but at least we can see if it was AI generated or not. Sounds right. I'll let Gareth explain what he's doing. In fact, Gareth, I'll let you take over. This is your subnet.
Yeah. Okay. Yeah. So sounds right. Subnet 105 was a very interesting use case for us because what they're doing is audio restoration. So if we're looking at a use case of someone who has an old bad quality video file, it's very likely that the audio is going to be bad as well. So we're going to partner with Sounds Right to offer something on the product where if you're upscaling an old video, that you can also restore the sound on the video. So I think that's a really obvious use case for us and for them. Hopefully, it'll be a great partnership. And Bitcast as well, which is the content creation marketplace. We've just bought a brief with those guys, so we're very much looking forward to the output with them, and they are really great at doing all things BitTensor. So they're really making some incredible content, so they're definitely worth checking out. And next slide, please, Mark.
Sorry, there we go. Sorry.
Okay. So yeah, so we've touched upon this earlier, just like what we're looking at the roadmap. Obviously, we've got the upscaling synapse that's ready. Video compression is, we're probably a month out from, getting some really good progress on that. We haven't got a launch date in there yet, but it will be very soon. Obviously, with the video compression, the transcoding optimization comes as well. I think Ahmed kind of showcased that and spoke about it. And then the next things that we want to do for the future are on-demand video architecture and live streaming through the subnet. So this is obviously going to be quite an undertaking and a very difficult use of the subnet and how we're going to do it. We're going to need decentralized storage solutions. We're going to need kind of edge servers, and we're going to need some type of decentralized CDN and delivery network. So this is something we're going to be heavily researching over the next few months. So I really think if we can have a decentralized streaming service that runs on the BitTensor network, it would be incredible. So yeah, they're the things that we've got in the pipeline.
This is, I think we should kind of, stop on this point and give it some space, because I think it's important. You guys are building with the intention of working with a whole set of other subnets on BitTensor. Hippias, yeah, Bitmind. Can you talk more about like how you want to build that interaction? Like how you see it being multiplicative in terms of value? Like why work with inside of BitTensor?
Well, so all of those subnets that we're looking at there are going to bring value to our product. Another subnet we could work with could be a computer vision subnet, possibly subnet 44 score. We could have someone put a video through our processing. While they're doing that, the computer vision can do all the metadata tagging. They can do all the face tagging. They can say, where there's a car, where there's a tree, where there's someone chewing gum. Then all of these data points, can be relevant for people in asset management services who are looking for content archives. So I think there's so many tools out there within the BitTensor network that can really accelerate our product and really give us great power. And it can be totally reciprocal. We can, if we're getting paid for a service while we're using someone else's product on their BitTensor product, then we can make sure that that there we have a reciprocal relationship in place. But not only that, also they're going to have more organic requests onto their network. So that's going to be good for their emissions. That's going to be good for their miners. That's going to be good for the ecosystem as a whole.
Real world example. Imagine you're building cars, automotive industry, and you need to have gearboxes built. You're going to outsource to a specialist company that does that has the experience, rather than building your own in-house gearbox specialist department. Why not go to the experts in that? And then at the same time, you're probably going to prefer to go to a company that has experience in the same industry, that's working with the same suppliers, with the same customers. You share reputation, so that their reputation bolts onto yours to put a level of trust, rather than going off to a metalworking factory that has no interest within the automotive industry. So by supporting everyone on the way up, and especially as BitTensor subnets are generally using a very similar architecture, often trying to achieve the same thing. We're trying to overcome the same problems together, especially in terms of revenue structure, value to alpha, value to the network as a whole, throughput. We're all getting together to solve bigger problems.
Yeah, there's so much value in the community, and there's so much crossover. And incentivism and the distributed network, and I just think, we're community. We love the community, and we want to keep it within it as much as possible.
I love to hear when teams are like surprised by the performance of the miners on BitTensor, and excited to see how like incentivization actually works. Like it's not just a joke. It's like you take your problem, you define it as an incentive problem, and all of a sudden you're just surprised by the quality. But speaking to like bringing it into the network, like how does this connection work from the validator, currently running a large portion of this network, like Mog? Are you using your bandwidth as a large validator to, like, are you imagining to use your bandwidth as a large validator to solve this connectivity?
Yes and no. Actually, I'll be 100% honest here. My view on bandwidth as a gateway to the network for validators to monetize has shifted over the last six to 8 months. I believe a lot of the responsibility for being able to generate that revenue falls on subnet owners and ourselves as validators. And I still believe, and I spoke about this at End Games, and you weren't there, but you'll see it when Shad puts my talk out in a couple of days. I still think there's a lot of unknown positioning for validators, where they find themselves, and they're all taking on very different roles. I mean, it's a bit off tangent. If you look at the role that's potentially Rizzo and Roundtable are taking, an OTF slightly differs from the role that Taostats is taking, which differs from the role that Latent is taking, now TAOAP. So we're all trying to kind of find our place and space. And if I speak from a personal point of view, currently Taostats believes that we should give our stake weight to the person that adds the most value to the subnet. If there is someone that is really adding value to the subnet, which should normally be the owner, and if not, at that particular stage, as we're not making a protest, we will look out for our nominators, of course, because they are our customers. And so in this instance, Vidaio team is the one that we believe deserves our stake weight, and we believe has the chance to bring the most value to the subnet. That said, it's not always a perfect situation. If you look at the metagraph, there does still need to be some tweaking to make an even rewards landscape for all validators. There's still a little bit of inconsistency that needs to be ironed out. Where majority stake is causing a slightly higher V-trust. I'm very well aware of that. But I wouldn't expect OTF or Rizzo or Roundtable to go off and build a video product. They could, of course they could, but they could do that using the API access that Vidaio, the company, offers. In this instance, when you buy API access or you purchase the usage of the product, you are going to Vidaio, the company, rather than Vidaio, the validator, if that makes sense. I know that's a changing landscape and it's very different for different subnets, but I'm not sitting there as Taostats thinking, how am I going to monetize the bandwidth that the network affords me? Because I do feel that narrative is shifting. Sorry, but that's my truthful answer.
Very truthful. This is a deeper conversation. We shouldn't side rail or diverge too much away from the presentation. Gareth.
Yes, back to go-to-market.
Okay. Yeah, so I mean, we've touched upon quite a lot of this before, but yeah, so initially, like if we look at the problems that we're solving, particularly with this compression model, is really something that the emerging markets are really going to lap up, because I've worked a lot of time in emerging markets, predominantly Africa, in the VOD and content delivery space, and the problem that they're having is they've got real bad connectivity and bandwidth issues. So if we can make these files 50, 60, 70, 80% smaller and still maintain the quality, then that's going to be a huge win for the network providers, the VOD platforms, and of course the customers and the end users. So I've got a lot of contacts in this market. We're already talking to some quite exciting players in this field, because once this product goes live, we can literally revolutionize like these delivery pipelines. We can cut their costs in half. We can make the consumer product better. There's so many things that we can do to help these businesses. So I'm going to lean on my or network that I have already, and we're going to aim specifically for the African market. But of course, once we've proven the concept, then we can just move this into any territory and any market really. So yeah, and almost strategic partnerships is almost like collaborations. Our product is going to be integrated into other products. So if you're a asset management provider, and then you're going to have Vidaio doing your video encoding. So if you're a CDN, you're going to use our technology to make your files half the size that they previously were, therefore saving storage and bandwidth costs. So these are all things that we're looking at. We're going to go business to business. We're going to say, these are the problems we can solve for you. And, we'll plug into already existing infrastructure that these guys have. So yeah, so that's kind of what that's our go-to market strategy over the next few months. And then I think, yeah, this is just some use cases that we've touched on before. So yeah, I don't think I need to go through these.
No, I was going to say, will we find you, Gareth, at crypto conferences in the next 6 months, or at media and video tech conferences?
Yeah, I mean, much more likely I'll be at VOD and streaming conferences, but I'll try and come to anything where BitTensor is represented, but not necessarily the crypto side, because I think we've got to go out there, we've got to go and knock on doors, we've got to make people in the non-crypto world understand what we're doing, because once they see our product, they're going to be excited, but people can be put off by the way that our decentralized network is formatted. So I'm going to be knocking on a lot of doors and explaining situations and showcasing our amazing product.
One question, I know I didn't make it through to the slides, and maybe you don't want to say, so you can defer. Have you had any interest, approval, or what's the word I'm looking for? Or is that the right word? From those that have reputations outside of the crypto space, within the video compression industry, who you could lean on as ambassadors as you go out into the wider world?
Yeah, totally. Yeah. So I mean, there's a few different people who are kind of big in the streaming and the video compression world. It is kind of quite a closed circuit, but the godfather of screaming was a guy called Jan Ozer. We've been talking. In fact, I've been talking to him since before we even launched the product. So he's been working with us, and he's gonna once we have the compression model up and running, he's going to run a piece on us, and he's got brilliant reputation. He runs a podcast, and he also he'll do some benchmarking tests against literally all of the other companies, and he'll release that as a paper. So we've got that coming up, and and then we're talking to a few other people in the industry who are working for some pretty cool companies. So there's a lot in the pipeline that we can't talk about, but I will share it all on X as soon as I'm able.
That was 1 hour and 40 minutes. Well done, guys. That's it. That's the last slide I have.
That's us. Yeah.
Where are the benchmarks where we shit on our competitors?
Which ones? The ones back here?
We didn't highlight that enough. I think this for me is, you guys know me. I'm such a stats person. I love the numbers. This is really where it shines. I do have one more question. So we're pushing performance. This is incredible. How about bandwidth? Like, how many videos are we compressing at this improved performance level?
Well, right now it's been live for 7 days, and the priority has actually been on UX. And poor old Akin had a holiday booked, and has been dividing his time between doing UX for Hippias and UX for video. And two subnets that started probably their lives 3 months apart. They started their journey, just happened to come to the point of being ready to go live at exactly the same time, where both of them then incurred various aspects of wrath from me for not, the UX not quite being up to where I felt it should be. And so I think a lot of the initial beta phase of upscaling has been about UX, feedback, uploaders, users seeing within the small pool of users who are aware of this. And as soon as that is up to scratch, it's a question of incentivizing the miners to perform and take through greater bandwidth. And the mining teams are there, and they are being well incentivized to up their capacities.
Very exciting.
And there will be minor dashboards and stats in order to show this rather than just me.
Who is your first customer?
Who was?
Who is?
So I mean, that's a good point. For the upscaling, I think we're just going to have a business to consumer app. I mean, it's already up in beta, so there can be customers. We can shout that one from the rooftops. But for the upscaling, we're talking to some quite large content owners in Africa who have. So it's kind of it's for the upscaling, like Disney, Netflix. These guys aren't going to use that at scale. But when you look at emerging markets and you look at someone who maybe has 500 SD movies that are just sitting on some hard drive somewhere that they can't really use, then they can send them to us. We can upscale them, and then they can literally repurpose that content for television, for VOD, for putting on YouTube, whatever they want, because people aren't going to look at these lower quality movies anymore. So we're already in talks with some big content owners on the continent. So I think that would be our first customer for scale on the upscaling model.
Do you have experience in Africa, Gareth?
Yeah. I've been working in VOD in Africa for the last 10 years. So with Canal Plus, who've got a big footprint in Africa. So I've been working with them on their African channels.
Interesting market.
Yeah, and it's a widely ignored market, and that's the thing, because it's a difficult market to work in, and people couldn't solve the problems that we're now solving. So it's really kind of ripe for the picking. So people are crying out for exactly the reason the whole subnet came about is because these are problems that I couldn't find solving in the marketplace. So that's why we kind of came up with the idea and built the subnet, because I know there's a real world use case for it.
And
Yeah.
really, truly, that's decentralization in action, right?
Absolutely, yeah. But I couldn't have done this without BitTensor. You know that we couldn't have had this these models. We couldn't have advanced so quickly. You know, we it's an incredible thing. Why would you do it the old centralized network and the mine isn't just like to them and
in the compute storage infrastructure market. I can't speak for the subnet. But I've had some initial calls with them just to guide them down some paths. But yeah, they are an African-based team, so we're not completely out of Africa.
That's good to hear. I am actually in Africa right now.
I know, but I wasn't going to dox you.
Yeah, it's okay.
Just
You can't find me. Guys, this was a surprisingly amazing presentation, and really interesting. Like I think that this problem, and I said this before in the conversation, it's one that makes perfect sense for decentralized computing and incentivization. We can, with this type of mechanism, just consume all of the latent computing power across the globe, really, in BitTensor, because there's no need for interconnect. So I'm very excited, both for what you guys are doing, which is incredible, and clearly from the statistics that you're showing that the miners are optimizing, but also for inter-subnet connectivity and how we can use the compute stores that we have in BitTensor to mine the subnet cheaper and et cetera, and really do interconnectivity between the digital commodities that we're producing. It was a perfect presentation. Thank you so much. Great team, Gareth and Mog. Thank you for being up on the stage. Let's end it here. I, for one, have not slept for a very long time, so I'd love the opportunity to get to that. So if you guys would let me go, we can end the call here. Thank you so much.
thank you, everybody.
thanks so much, everyone.
Thanks
Thank you, John.
all.